Hi, my name's Mr. Townsend. You can call me Mr. T, and I'm going to just go through an example of how to answer the 2013 Organic Chemistry paper for the NCEA exam. I'll go through each page and give you how I would answer and just some tips along the way. I hope you find it useful. Right, question 1 on this organic chemistry paper. First thing to notice is we have 60 minutes to do this, and we just want to make sure that we have fun and we take all the time we need to, that each question is done comprehensively. So first question is, they want, there's a structure of some organic compounds containing chlorine shown below. Write the letter of the molecule that is a secondary chloroalkane. Okay, classification. We know that we classify either alcohols or haloalkanes depending on how many carbons are attached to the carbon that the functional group is joined to. In this case, there's only one molecule that has a functional group attached to a carbon that is joined to two other carbons. So A is our molecule that has a secondary chloroalkane. Okay, they want us to tell us why. Well, we kind of just said that, but let's write it down. Describe why we chose this molecule. So in this case, it's because the carbon the cell is attached to I could write bond here, that might be more specific, to is bonded to two other carbons. Cool. It's unlikely that the first part of the answer is going to get you any marks. It's really the explanation afterwards that will get you some marks. Right, B. Identify two molecules on the table that are constitutional or structural isomers. Remember, constitutional isomers are molecules that have the same number or the same molecular formula, the same number and type of atoms. And well, let's write this down for the second part of the answer. Identify two molecules, justify your choice. No, let's do it first. Same number and type of atoms, but they're arranged in different ways or bonded in different ways structurally. So let's have a look at these. Okay, so well, this one here has 4 carbons. Okay, this one here has 3 carbons. 4 carbons, 4 carbons, 4 carbons, 4 carbons. Cool. Automatically, let's get rid of that one. Wait a minute. Let's just double check here. That one has 3 carbons. So they had 3 carbons, and that one had 3 carbons, but 2 chlorines, right? And 1 chlorine. So we'll get rid of both of those. Okay, so we're happy there. Let's have a look at the chlorines then. This one has 1 chlorine. This one here has 2. This one here has 1. This one here has 1. So the one with 2 chlorines is the odd one out. So it can't be the same molecular formula as any of the others that are left. So now we have 1, 2, 3, 4. Let's have a look at the hydrogens now. So this first one, 3, 4, 6, 9 hydrogens. This one here, 3, 5, 6, 7 hydrogens. 2 hydrogens less, that's going to be an alkene, that one. And 3, 5, 7, 9. So it says 9. So that one there, being an alkene, is not going to be an isomer. So our isomers, our structural isomers or constitutional isomers, which they like to call them these days, are A and F. Okay, let's put this on here. A and F. So they have the same molecular formula or same number and type of atoms. Number and type of atoms. Now I can be specific. Both have four carbons, one chlorine and 9 hydrogens, and they are bonded together differently. They are arranged in a different way. Let's say that. A different way. Specifically, you know, they're going to have different names because let's give a wee bit of detail here just to be sure. Okay, so the chlorine comes off the second carbon in A and it comes off the first carbon in F. The Cl, the second carbon in A and the first in F. So I'm not going to actually give them any reason to think that I don't understand what I'm talking about, because I've been specific here and said, look, the chlorine is off two different places in each of these molecules. That's why they're constitutional isomers. So I'm giving the detail they need to be able to give me a comprehensive understanding for this answer. Right, question 1, part C. Molecule D, which I'll just redraw here, CH3, CH2, CH, CH, Cl. Okay, so notice that in this point here, we're missing hydrogen and one here as well, so there must be a double bond in between the two carbons, and that makes sense because here they're saying that this molecule D, can be geometric isomers, and we know the first thing we know about a geometric isomer, in order to be a geometric isomer we have to have a double bond somewhere. Okay, the other thing we know about in order to be a geometric isomer is you have to have a different substituents or different groups coming off either carbon. Okay, so what they want us to do here is draw a cis and trans. Trans means across, so let's do the trans one first. We're going to take these two carbons here and just focus on drawing these before we add the other groups. So put the double bond in, right hand side, here's my hydrogen, here's my chlorine. Okay, so I want this, well, that's not my chlorine at all. We'll redraw that again. Okay, here's the chlorine. So what we want to do is we want to have this as a trans arrangement. So we notice on the other side what we've got is another hydrogen. So we'll draw that there. So that means our other group, which is our CH3, CH2, must come off that one there. That makes this a trans arrangement. Again, with the cis, let's draw our hydrogens and cis, chlorine up the top here, and CH3, CH2, and there we go. Done. Okay. Justify why. Okay, same as the other one. They've asked us to do do an exercise, and now they want us to justify it. So we're basically just putting the ideas that we use to draw this. We're just writing them down so that we can give an in-depth answer. So in this case, explanation required for cis and trans, and reference to the structure of this molecule. Okay, so number one, we had needs a double bond. Needs a double bond. Obviously this is pretty apparent, and the other thing it needs is two different groups off each carbon. Each carbon. Obviously in this case it's pretty straightforward. Okay, so we've got the two different groups. Because it has two different groups, the hydrogen and the chlorine on one side, and the ethyl and the hydrogen on the other side, we can get these two different arrangements. So reference to structure D, let's say it has D has a hydrogen and a chlorine coming off one carbon of the double bond, and a ethyl and hydrogen coming off the other. Okay, pretty straightforward. Needs a double bond, two different groups off each carbon. We've referenced it here by saying it's got the hydrogen and the chlorine coming off one carbon, included to say it's got a double bond, and ethyl and hydrogen off the other. I could go on and say that because of this, the hydrogens can be across from each other or trans, or on the same side of the double bond and be cis. That might make this a more fuller answer, but I'll just keep going on and I'll come back if I need to say that, if I have time. Right, part D. Okay, we knew this was going to come. This is us drawing the formula and naming organic compounds. So hopefully we've put all the groundwork into learning the prefixes and the suffixes for the different types of functional groups and for the number of carbons. So let's start out here. So first one, pentanoic acid. Okay, so the pent, I'll start with that. Because it's got the pent prefix there, we know that it's going to have 5 carbons in the main chain. We've then got the anoic acid bit. Carboxylic acid, we know that there's going to be a double bond O, OH at the end. Okay, and then once I've done that, there's nothing else untoward on this, no other names in the front, so we're just going to fill in the hydrogens. So just easy work, you can get it. Okay, sorry about the mess here. So there we go, pentanoic acid, pretty happy with that. We've got acid functional group, and 1, 2, 3, 4, 5. There's no numbers or anything, pretty straightforward. Okay, next one looks a bit more difficult, but again I'm going to start with the parent chain, and here we've got a bute, and it's an ene, which means it's going to have a double bond coming off the first carbon here. So let's draw that first. I'm going to draw 1, 2, 3, 4, double bond off the first carbon. That's the main part of the name done, and now I've got the first part here, a 3-methyl. Okay, so the bit we need to take care of here is that because I put the double bond here, this is number 1 carbon, so the third carbon is going to be coming off here. So I'm going to draw my methyl group of the third carbon, CH3, okay, and then chuck in the rest of my hydrogens. Now just take care with this part here that we only have 4 bonds coming around. One of the big mistakes that people make when they're doing tests or exams is that they just chuck in a couple of extra or an extra bond here because they fail to recognise the double bond is contributing 2 bonds. Okay, so make sure you take care there. That should only have 4 coming off each carbon. So let's double check this, and yep, 4 off here, 4 off here, 4 off here, 4 off here. So I'm pretty happy it's double bond off the first one and the methyl group off the third one. Okay, let's move to the next one. Okay, in this case here, now what they've given us is the formula. It's a condensed formula, but we're not going to get too worried about that. If we were felt more comfortable with using the expanded formula like this, we could draw it out again, but I'm not going to worry about that here. We've got 3 carbons, and we've got this amine group. 3 carbons gives us a probe or prop. Okay, so it's going to be propane, and we've got this amine group coming off the number 1 carbon, so it's 1 amino propane. Okay, pretty happy with that. Not so much with the messy writing here, but let's move on. Okay, so it gets a wee bit more difficult here because in this next case we have 2 functional groups. Again, it's a propane. We've got an OH here, hydroxy, or will cause an alcohol functional group, and we've got a chlorine, which will give us a haloalkane. So we've got both in the molecule. There's 2 ways we can name this, but we'll name it the way that where we put the alcohol functional group at the end. Okay, so basically here what we've got is a propan 1-ol. Okay, because what we want to do is give the smallest numbers we can to these. So if I number it from the right hand to the left, I get the OH is at carbon number. Let me just get this right here. Okay, OH is off number 1, the Cl is off number 2. If I number it from the right, if I numbered it from the left, the Cl would be off number 2 and the OH was off number 3. So I'm going to number it from the right. So I get propane 1-ol. Okay, and I've got this chloro coming off the second one, so it's 2 chloro propane 1-ol. Cool, pretty happy with that. And we get on to the last one here. Last one here is, if we have a look at it, there's no specific functional groups apart from a methyl group. And look at this, they've tried to trick us by drawing it bent. Okay, so this is kind of basic stuff. The teacher would have done this at some stage just to make sure that you understand that we just take the longest chain. The longest chain here is hexane, and we've got a methyl group coming off the first, second, third carbon. Alright. So in this case we've got 3-methyl hexane. Cool. Right, just double check what I've done here. Get this down. Pentanoic acid, 1, 2, 3, 4, 5, yep, happy with that. Bute, 1, 2, 3, 4. 3-methyl, yes, here it is here. 1-ene, yep. 1-aminopropane, prop, yep. 2-chloropropanyl, 2-chloropropanyl, yep, that's all good. And 3-methylhexane. Okay, yeah, I'm all pretty happy with that. I'll move on to the next page.